Good morning to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? Very good morning to all of you. Yes, I think we are live. First of all, do comment करके बोलिए now. Is the audio videos clear to everybody? Right. I think we are live. So सबसे पहले बोलिए now here. So a great news to all the aspirants who are seriously prepared for 2027 2028 के लिए. So Unacademy आपके लिए बढ़िया से बढ़िया ऑफर लेकर आया. Now this Unacademy subscription that is just 8,999 only. You will get flat 60% of discount and इसके साथ आपको extension भी मिलेगा. Free extension भी आपको मिलेगा. Use the code of BV Reddy and to avail these opportunities. You can use my personalized invite code to avail this great opportunity. Right. So first of all, do comment करके बोलिए now, is the audio video is clear to everybody? Now this Unacademy subscription that is just 8,999 rupees only. Use the code of BB Reddy and to avail these great opportunities and to have a great learning experience from the top educators team. Unacademy special class festival, which is from 9th to 11th. With this, you can able to experience the how the Unacademy platform. You can able to explore the Unacademy platform. So chat with the top educators, attempt interactive polls, and gets clear all your doubts. You can clear all your doubts. And so these are the Unacademy team of the top educators. You can find here. We're starting new subject. We are starting digital and EMFT. EMFT I'm starting from 11:30 a.m. from the 12th June onwards. So here these are the 2028 के लिए नया batch. So we are starting the digital and then EMFT. And so Unacademy, so to get 2026 ka rankers you can find. These are the ESC 2025 ka rankers. ESC 2025 ka rankers from all the different branches. Right, we do offer the two subscription, that is plus subscription and the iconic subscription. प्लस में आपको क्या चीज मिलेगा? टॉप एजुकेटर्स क्लासेस, लाइव डाउट्स एंड evaluated test series, structured courses, live test, unlimited access. आइकॉनिक में एडिशनली क्या बेनिफिट्स होगा आपको? पर्सनल कोच भी मिलेगा, फिजिकल नोट्स भी मिलेगा एंड आस्क ए डाउट फीचर and all the plus features are included here in the iconic mail. You can start your serious preparation with the Unacademy. Regarding any doubts, you can book a slot and connect with your mentor. Start your serious preparation. So let's crack it. चलिए, the last class we did some problems, some practice questions हमने किया from CIL के लिए. Now we are going to continue those things. Earlier we did the DC circuits. Now onwards we are going to do the AC circuits, and these are the very important. So from AC circuits से हमके ज़्यादा से ज़्यादा problems आएगा. Let's focus now here. Let's try to understand one by one. So here, chalo, first take the first problem. and alternating EMF is given as like this. AC voltage given. Apply to a capacitor, the RMS value of the current in the circuit is. So first of all, you can have a look at now here. The given alternating EMF is given. How much is EMF now? This AC voltage, which is given as 110 root 2 into what you tell me now, sine of 100t. Sine of 100t, this much. And so from this we need to get this current now here. The current which is equal to EMF by capacitor. Reactance of capacitor is what, tell me now? 1 by j omega c. So we'll come it as what, tell me now? J omega c into E. So we can simplify now here. J into omega value how much now? 100. Capacitance value 2 into 10 power minus 6. And then E. E value how much now? 110 root 2. Yes, into what I'll get now here? Sine of 100t. So then this I value which will come to be what, tell me now here? This is J. Yeah, you can see, check for cancellations now here. 1, 2, 3 zeros will get cancelled. So this is minus 3. So milli में आएगा हमको. So 22 into root 2. Yes. Into 10 power minus 3. Into we have this as sine of 100t. This is the current. Whether J means it is a 90 degrees, will be going to the 22 root 2 into what I can say now here sine of 100t. J means plus pi by 2. And this we can write as milliamperes. This is the current. They ask him to find what current here. RMS current they asking. So what is IRMS equal to what, tell me? So that is IRMS, which is equal to what you tell me now? I naught by root 2. So what is this IRMS will come, tell me? I naught. So that is 22 root 2 by root 2. So which will come to be a what you tell me now? IRMS value, which is equal to 22 milliamperes. Okay. Next one. The AC current at any instant is given as like this. The RMS value is, yes, RMS value here directly we can say now frequencies are different. If the frequencies are different, we can do it as what, tell me now here? IRMS. IRMS, which is equal to what you tell me now here? This is I naught square plus what, tell me now here? Yes, so this is I1 square by 2. I1 square by 2. So you can tell me now here. So this is I naught square DC value, which is given as 36, and square of this, which is a 56 by 2. So I will come to be a what, tell me now? Square of 36 plus 2 into 8. So how much will come here? This is square root of 14 and this is 64. So how much is IRMS value, which is equal to 8 amperes. Next one. An AC voltage is applied to a purely resistive load 50 ohms. The time taken for the current to rise from half of the peak to peak value. half of the peak to peak value, time taken by the current. So first of all, we can say now I is equal to what we can say now, V of t by resistive load is R. So which will come to be what will be now 220 by 50 into what I can say now, this is sine of 100 pi t. Okay, here they didn't asking about the current value, they asking the, for what you tell me now, half of the peak to peak value. I can treat simply I value, we can treat as a I naught into, that is sine of 100 pi t. 100 pi t. So the whole thing is we have taken as simply I naught. They are asking to find, tell me now here, rise from half of the peak to peak value. So that means I naught by 2 to I naught. So this means at t is equal to t1. So this current I is equal to what you tell me now here, I naught by 2. Now when t is equal to t2, this I value which is equal to what, tell me now here, I naught. And we'll substitute them. So then, so this value which is equal to I naught by 2, which is equal to I naught into, that is sine of 100 pi into t1. So how much will come here? That is sine of 100 pi t pi t1, which is equal to 1 by 2. So this value 100 pi t1, how much this value which is equal to sine 30, that is pi by 6. Pi will get cancelled. So we'll get the t1 value as what, tell me now, 1 by 600. 1 by 600 seconds. Now we need to get the t2 value now. T2 condition we can substitute. Yes, T2 condition is what, tell me now here. So this value which is equal to I naught, which is equal to, this is I naught into sine of 100 pi T2. So tell me I naught will get cancelled. So this value 100 pi T2 and which is equal to 1. So 1 means, this value sine 1 means pi by 2. Pi will get cancelled, so that T2 will come to be a what, tell me now, 1 by 200. 1 by 200 seconds. Now they ask him to find the time interval. So this is delta T we can find. So that is T2 minus T1. Yeah, simplify, how much will come, delta T is a T2 minus T1. So what I'll get now, 1 by 200 minus 1 by 600. Yes, so here LCM how much? Delta T. LCM is equal to 600. So this value 3 minus 1. So which is equal to 2. So this value will come it as 1 by 300. 1 by 300. So this is 3.3 milliseconds. Next one. In an AC circuit, voltage and currents are given like this. The average power. Yeah, what is this average power? You tell me now. P average. So, what is the average power? P average. Average power means which is equal to P na active power and which is equal to what, tell me now, VRMS, IRMS into cos phi. VRMS, IRMS into cos phi. So you can tell me now what is the VRMS is a, that is 100 by root 2. IRMS is also 100 by root 2, and this is cos phi, means cos 60. Cos 60 value how much? So this is 100 into 100 by 2, cos 60 value 1 by 2. So will come 50 into 50. Okay, this current is given milli given. So that's why 10 power minus 3 also will come. 10 power minus 3 also. So this is 3 zeros will get cancelled now. So the p value how much will come here? That is 5 by 2, 2.5. So 2.5 watts active power. Next one. An alternating EMF is applied to a circuit containing an inductance is given. An AC ammeter is connected. AC ammeter will measure what current? RMS current. So we need to find the RMS value. EMF is given, so we can get this current now here. The current is equal to what we can say now? E by, so inductive reactance is J omega L. E means how much now here? 440 into what I can say now? Sine of 100 pi t by, so this is J omega value 100, L value is how much now? 100 pi now, omega value 100 pi also there. Omega value 100 pi, so this value root 2 by pi. And now we can simplify it now. So this pi will get cancelled. So how much will come here? I value, tell me now here. This is minus j into, so this is 4.4 by root 2 into 100 pi t. This is the value of current. Now we need to get ammeter reading now. So what is this one? RMS value we should get. So what is this RMS value? IRMS, which is equal to what? Tell me now. I naught by root 2. So that's why here RMS value, which is I naught, which is equal to 4.4 by root 2 into again root 2. So will come it as 4.4 by 2. So it will come to be what? Tell me now. 2.2 amperes. So option C. Next one. The equation of current in a purely inductive circuit is given like this. Okay, if the inductance is 30 millihenry, then the equation of voltage is. Now we need to find the voltage across inductor. Voltage across inductor, which is given as, that is J omega L into I. So this is VL, which is equal to J omega. Omega is what? Tell me now here. 49 pi. Yes, into L. Inductance value 30. So this is 30 into 10 power minus 3 into 5 into sine of 49 pi t minus 30. So then VL will come to be a what? Tell me now here. J into 49 into pi is 22 by 7 into this is 30. We can multiply also here. So this is 150 into 10 power minus 3 into sine of 49 pi t minus 30. and try to simplify this thing. So this is 7's na. So then we'll come it as VL value, which is given as J into so this is 7 into 22 into 150. Yes, into 10 power minus 3, which will come to be a 23. 23.1 into sine of 49 pi t minus 30. Here J means angle plus 90 taken to inside. So this value 23.1 sine of 49 pi t minus 30 plus 90. So we will come it as 60. So VL, which is equal to 23.1 into sine of 49 pi t plus 60. So option D. Got it? Next, try this one. A direct current of 4 amperes and an alternating current of peak value 4 amperes flows through a resistance 3 and 2 respectively. The ratio of heat produced in the two resistors in the same interval of time. So that means indirectly they are asking to find the power. Yes, now they're given a DC case power P1, which will be equal to what? Tell me now here simply I square into R. I, that is 4 square into R value, how much now? 3. Now, when you have taken this AC case, the power AC power, which is equal to I RMS square into R. RMS value, that is 4 by root 2 whole square into this value 2. Now we need the ratio of these powers now here. So we can say now here P1, which is equal to 16 into 3. And this P2, which is equal to what? Tell me now here. 16 by 1, 2 will get cancelled. So the ratio of these powers, they are asking P1 by P2, and which will be equal to 3 by 1. Next one. The current flowing through an AC circuit is given by how long will the current take to reach the peak value starting from 0. How much time will take? Peak value. So this is I is equal to of the form. This is I naught into. So this is sine of 120 pi t. Peak value I naught equal to, we can say this as I naught into here this I naught will get cancelled. So we have this is what will be now sine 120 pi t1, which is equal to 1. 120 pi t1, which is equal to how much now? Pi by 2. So we'll come it as what you tell me now, t1 is equal to 1 by 240. Next one. As shown in the figure, an inductor of inductance 200 millihenry is connected to an AC source of EMF 220 50 Hz frequency. The instantaneous voltage of the source is 0 when the peak value of current is this much. Then the value of A is. Peak value of current is given. Instantaneous voltage of source is 0. Okay, at some instant they given this value 0. They ask him to find what, tell me now here, current. So first of all, this current is I, which will be equal to, so EMF voltage by inductor na J omega L. So which will be equal to 220 by, this is J omega value how much? So this is 100 pi. Omega value 100 pi J omega L. L is how much? 200 milli. 200 into 10 power minus 3. So then I value will come to be what, tell me now? So this is minus J 220 by, so will come it as what, tell me now here? So zeros we can cancel it now here. How many zeros now here? 1, 2, 3 zeros will get cancelled. So will come it as 20 pi. 0 will get cancelled. So this value, peak value, will come it as minus J 11 by pi, isn't it? Hmm. 11 by pi. So this all these values they given what, tell me now? Peak RMS value. So they're asking peak value now. So this is a RMS current we got. And peak current means I naught, which is equal to, so we can say now 11 root 2 by pi. So then this value which will come to be a what, tell me now? This 11 means that is square root of 121 into 2 by pi. So then I naught value will come it as what, tell me now? So this value square root of 242 by pi. So these options are wrong option. It's a numerical, no options here actually. So A value how much now? Root 242. Next, a resistance of 40 ohms is connected to a source of alternating current rated 220 volts 50 Hz. Find the time taken by the current to change from its maximum value to RMS value. Time taken by the current. So then general form of this current I, which will be equal to what I can say, I naught into, that is sine of omega t. They are asking the time taken to move from where to where maximum value to RMS value. When t is equal to t1, this current is maximum, means that is I naught. When t is equal to t2, the current what they are saying here, that is equal to RMS value, that is I naught by root 2. Okay. Now let's simplify now here. When it is I is equal to I naught equal to what you tell me now here, I naught into sine of omega. So omega is 100 pi. T is a T1. How much will come here? So this is 100 pi T1, which is equal to sine 1 means pi by 2. So this value T1 value how much now? 1 by 200. Next second condition is I naught by root 2, and which is equal to what, element of here, I naught into, that is sine of 100 pi into t value t2. So this I naught will get cancelled. So how much will come here? This is 100 pi T2, which is equal to 45 na pi by 4. Pi will get cancelled. So that is T2, which will come to be 1 by 400. Now, so we need to get the time interval means delta T, which is equal to what you tell me now here. So T1 minus T2. Simplify now, delta T is a T1, that is 1 by 200 minus 1 by 400. So the delta T, which will come to be a, this 400 is a LCM, so this is 2 minus 1. So delta T will come to be a 1 by 400. So that means delta T, and which is equal to how much now? 2.5, no? 2.5 milliseconds. Right. Fine. Yeah. Right. Okay. Yeah, that's it for this class. And today at 11 o'clock in Unacademy platform, we have a special class is there. There I will discuss the continuation of these problems. And do join at 11 o'clock in the Unacademy app. Say. In Unacademy app, you can search my name, BV Reddy. There you can get the my latest course, the course which we have at 11 p.m. we have, and there will continue the remaining problems will continue. Okay, so do join at 11 o'clock. So we'll meet 11 o'clock. Okay.